to look at part 2 of factoring polynomials. Okay, I want to factor this. Again, I want to look for my greatest common factor. The GCF is 1. So I've completed step 1. Now I want to look at step 2. How many terms does it have? It has 2 terms. So if I can factor it, it's either going to be the difference of squares, the sum of cubes, or the difference of cubes. And notice that x cubed is a perfect cube. And notice that y cubed is a perfect cube. I have a subtraction sign, so it's going to be the difference of cubes, which means I'm going to use a pattern that says a cubed minus b cubed equals a minus b times a squared plus a times b plus b squared. Okay, in order to do that, I need to find out what a and b is, what a and b are. Okay, to do that, I'm going to take the cube root of x cubed, which is going to be a, and the cube root of x cubed is x. I'm going to take the cube root of y cubed, and the cube root of y cubed is y. And in my pattern, everywhere I have an a, I'll put an x, and everywhere I have a b, I'll put a y. So I have x minus y times x squared plus xy plus y squared. And that's my final answer. Let's look at another example. This time I have 16m cubed plus 2p cubed. Okay, I know it's a binomial, but I'm always going to start with my greatest common factor. I'll look at the coefficients. The greatest common factor of 16 and 2 is 2. I'll look at the variables. They don't have a common factor, so my GCF is 2. And as we said in the earlier video, we're going to divide both terms by the greatest common factor, 2. And so when I factor this, I have 2 times 8m cubed plus p cubed. Now I'm not completely factored. All I did was take out the GCF. Now I need to see if I can factor this. It is a binomial, so my choices are difference of cubes. It's not a difference because it's not subtraction. Sum of cubes. Is this a perfect cube? Yes. Is this a perfect cube? Yes. So I'm going to use the pattern for sum of cubes. Sum of cubes says a cubed plus b cubed equals a plus b times a squared minus a times b plus b squared. And again, I have to decide what a and b are. I'm going to take the cube root of 8m cubed, and that's going to be 2m. I'm going to take the cube root of p cubed, and that's going to be p. And just like I did in the previous example, everywhere I have an a, I'm going to put 2m. Everywhere I have a b, I'm going to put a p. So I have 2m plus p times 2m squared minus 2mp plus p squared. Now I want to simplify this expression here. I have 2m plus p times 4m squared minus 2mp plus p squared. Now that's just factoring this part. I still need to bring down my greatest common factor, which is 2, and this is my final answer. My next example is x squared plus 4x minus 12. Alright, I'm going to look for the greatest common factor as always. Since the coefficient here is 1, I just now need to look at the variable. This one does not contain an x, so I know that my GCF is 1. I know I have 3 terms, so I'm going to look at my graphic organizer. and it says my leading coefficient's 1, I'm going to use product sum. Now the cool thing about trinomials is that when they factor, they're going to factor into two binomials. Product sum, we're going to make the x. We're going to put the product on top. The product is always my c term, so negative 12. We're going to put the sum on bottom. The sum is always my b term, in this case the 4. So I need factors of 12 that differ by 4, because in order to get a negative, I'm going to multiply a negative times a positive. So I list my factors. I have 1 and 12. I have 2 and 6. I have 3 and 4. These differ by 4, so I know that's what I'm going to use. I have to decide which gets that sign. I need a positive 4, so my largest factor of 6 is going to get that sign. Okay? In order to get what I start with in my binomial, I'm going to take the square root of this, because remember I had to multiply to get that. So in order to get x squared, I had to multiply x times x. And to get the remaining terms in my binomial, it's going to be minus 2 and plus 6. And if I multiply those out, I will get the trinomial. So here's my final answer. Pretty simple. Okay, I have another trinomial, but this time I notice that they all have an even coefficient. So my GCF is 2. Again, I'm going to divide by my GCF. I get x squared plus 5x minus 6. And remember, my GCF goes in front. Now the question is, can I factor that trinomial? Well, we're going to use product sum because we have a leading coefficient of 1. My product is negative 6. My sum is 5. Factors of 6 that differ by 5. So I have 1 and 6. Wait a minute, they differ by 5. So I can stop. In order to get a negative, I multiply a negative times a positive. I need a positive 5, so 6 gets the positive sign, and 1 gets the negative sign. And again, like I told you, a trinomial is going to factor into two binomials. In order to get x squared, I multiplied x times x. I have a minus 1. I have a plus 6. And I bring down my greatest common factor. There's my final answer. Okay, this time I have a trinomial. It does not contain a greatest common factor other than 1. But I notice that my leading coefficient is not equal to 1. And remember, the leading coefficient is the number in front of x squared. So I'm going to use a method called bottoms up. And if you look on your graphic organizer, it has the steps. Step number 1 tells me to multiply a times c so that I can force this to be a factorable trinomial. So I have x squared plus 7x minus 30. And now I can use product sum. I have negative 30. I have positive 7. So I need factors of 30 that differ by 7. Because if this is negative, again, my signs are going to be different. Alright, so I have 1 and 30. No. I have 2 and 15. No. I have 3 and 10. I can stop. 3 and 10 differ by 7. It means 10 gets the positive number, or the positive sign, and 7, 3 gets the negative. Like we said earlier, if it factors, it's going to factor into two binomials. The square root of x squared is x. So I have x and x. I have minus 3, and I have plus 10. But guys, you need to remember, this was not my original. My original was 6, x squared plus 7x minus 5. I multiplied by 6, so now I'm going to divide by 6. We have to reduce the fraction. So I have x minus 1/2 times x plus 5/3. But remember, with bottoms up, it says no fractions allowed. So I'm going to bottoms up and move the denominator on the bottom up to make it a coefficient. So my answer is going to be 2x minus 1 times 3x plus 5. And if I multiply that out, I will get the original, which was 6x squared plus 7x minus 5. There's my final answer. Okay, this video is also getting long, but I only have one more example. My last example is a 4-term polynomial. Okay, with 4 terms, it says we're going to do factor by grouping. You want to make sure that they're in standard form, and this one is, and then I'm going to split them up. I'm going to factor the GCF out of this term. GCF appears to be 2x. And if I divide both these terms by 2x, I get 6y plus anything divided by itself is 1. I come over here, my GCF is 5. I divide both these terms by 5. I get 6y plus 1. Now I notice that I have a greatest common factor of 6x plus 1. So I'm going to factor that out, or 6y plus 1, excuse me. And I'm left with my greatest common factors, which I make into a binomial. 2x plus 5. And I have completely factored that term. And that is how we do factor by grouping. Okay, we're going to practice some more of these in class. Sorry that the video is so long. I'll see you in class. Bye.